Right, so this is the first question in the 2024 Biology Paper 2 internal exams. Question 1 reads, Figure 1 shows an experiment on osmosis. So we have this setup where we have the label F and the level of glucose solution in the tube, of which the name I'll provide for you. And then we happen to have the level of water. As you can see, there is a beaker where we have water inside. And in this beaker, there is another tube, which is G. There is this tube, which is known as G. And inside of this tube called G, there is glucose solution. Apparently, the one which is rising. The reason why we had the words level of glucose solution. So in short, in this thing down here, we have water inside, and the level of water, as you can see, is up there. And inside of the same beaker, we do have the tube, which looks like, a sack, a tube. And inside of it, there is glucose solution. The tube is called G, and inside of it, we have the glucose solution. A, they are saying, identify the parts labeled F and G. F and G. So F is no other than capillary tube. F is no other than capillary tube. G is no other than a dialysis tubing. A dialysis tubing. A dialysis tubing. So F, capillary tube. G, dialysis tubing. That's where glucose solution is. B, state the property of G, which means state the property of the dialysis tubing, which makes it to function in the experiment in figure 1. What exactly is the feature? What exactly is the feature? What exactly is the feature of the dialysis tubing? All right, which makes it to work in this experiment. Remember very well, let me say, you have to know what is happening right here. Water is coming out of the beaker and it's entering. All right, water is entering into the dialysis tubing. All right, it's entering into the dialysis tubing. So for water to be entering like that, what exactly do you think is the property that is enabling the dialysis tubing to allow water to move like that? What exactly is it? So there are so many actually. Number one, it's narrow. It's narrow. Number two, it's porous. It's porous to small materials. So it's narrow, it's porous. Yes, it's porous, which means it has got some pores, which will enable this one to work. There are so many. And the best answer that you can give here, it's a semi-permeable membrane. Okay, it's a semi-permeable membrane. That's one property I would want you to give during your exams. It's a semi-permeable membrane, which means it allows some materials to enter while resisting others. Question C, at the end of the experiment, explain how the following would have changed. C1, level of glucose solution. What exactly do you think glucose solution in the dialysis tube, in the G, will be? Well, the answer is very simple. It will rise. The level of glucose solution, the answer is will rise. It will rise. The level of the glucose solution will rise. C2, they are saying level of water in the beaker. The level of water in the beaker, because water was getting from the beaker into the dialysis tube. Remember, the dialysis tube has got glucose solution, which is sugar solution. So the sugar solution is attracting water from the beaker, from the beaker, the water that is in the beaker, and this water is entering into the G, into the dialysis tubing. So you expect the level of glucose solution in G, which is moving through the capillary tube, to rise. It will rise. But the level of water in the beaker, which is the level of water in the beaker, all right, will fall or will decrease, will go down. So glucose solution, the level will rise. Okay? Water in the beaker, the level will drop. D, what control experiment could be carried out alongside the experiment in figure 1? What control experiment could be carried out alongside the experiment in figure 1? Here, they are simply asking you, I think you know, let me explain in case you don't know. The control experiment. A control experiment is an experiment whereby every other thing will remain the same, but you change one thing. Every other thing will remain the same, but you change one thing. So one control experiment that we could use alongside this experiment is simply maintaining everything but changing water to distilled water. Remember, they haven't told us that this is distilled water. So we can replace this water with distilled water. Let me say we can set up another experiment and set up everything, every other thing, the way this everything is looking here. But water, we use distilled water. All right? So you simply say, by using distilled water instead of the water that is used. So using distilled water. E, name two other methods of movement of particles of a substance apart from the one demonstrated in figure 1. They're simply asking you for movements. The other two that we have, active transport and diffusion. You come from our WhatsApp tuitions. Yeah.